Alright, in this video I'm going to look at solving a trigonometric equation where I have a multiple of an angle inside my trig function. Right? So you can see I have 2 sine of 3 theta minus 1 equals 0. So it's not just sine of theta, it's a multiple of theta, it's sine of 3 theta, right? 3 times theta. Now, I just did another video where I had something somewhat similar to that. It was like a sine of 2 theta and then a cosine of 1 theta, or just cosine theta. And I said in that video, or with that problem, if you watch that video, that we couldn't do that because one of our angles was 2 theta and the other one was a 1 theta. And since they were 2 different angles there, I couldn't really solve it. So I had to use like a double angle formula to replace that sine of 2 theta with things that were just a single 1 theta. Now, in this problem, I don't have to do something like that because I only have the one single trig function, and it only has this angle 3 theta in it. So I don't have to like look for formulas here to replace that sine 3 theta with something else. I'm just going to go ahead and solve this equation as if it was sine of theta, and basically get that 3 theta by itself. And then once you do that, you just divide both sides of the equation by 3 to get your final answer. Right? So there's nothing real fancy for this one, although it can get a little weird when you start dividing that thing by 3 at the end. But let's go through those steps and just solve for 3 theta first. Right? So think of it, if it helps, you can put that 3 theta in parentheses. I got to figure out what 3 theta is equal to. So I want to get the sine function by itself, which means I'm going to add the 1 to the other side. All right, and then I'm going to divide both sides by 2. All right, so I'm going to get sine of 3 theta equals positive 1/2. Right? I added the 1 over, so I have a positive 1 on the other side, and then when I divide by 2, I get positive 1/2. All right, so sine of 3 theta equals 1/2. Now, again, at this point, don't worry about that. That's a 3 theta there. Just think of it as like sine of x equals 1/2, or sine of whatever, any variable equals 1/2. All right, so I want to figure out for what points on the unit circle will the sine function equal 1/2. All right, and if you've been watching the videos that I've done on the trig functions, I keep getting sine is equal to 1/2. It's happened in like 3 or 4 of the examples that I've done in these videos of solving the trig equation. So if you've watched those videos, you should probably know the answer to this by heart by now. But if you haven't seen it, I'll walk you through how to get it. All right, so I'm looking for sine equal to 1/2. Again, I don't care so much about what that angle is right now. Just where is sine equal to 1/2? Remember, sine is the y-coordinate of your terminal point. So if I use my trig hand, if I put down my ring finger, which corresponds to the angle pi over 6, right? Above I have root 3 over 2, that's my x-coordinate. Below I have 1 over 2, that's my y-coordinate. Right? So the terminal point here would be root 3 over 2, 1/2. Right? That has a y equal to 1/2, and that angle is pi over 6. All right, so that's going to be one of my solutions there. It's going to be the pi over 6. And then the other solution, I take that y equals 1/2, I reflect it over into the second quadrant, right? Because that point over there is going to have an x-coordinate of negative root 3 over 2, but the y is still positive 1/2. Right? When I reflect from the first quadrant to the second quadrant, my x turns negative, but my y stays positive because that y is still above the x-axis. And so these 2 points have the same y-coordinate, which means they have the same sine value, right? Because sine is the y-coordinate of your terminal point on the unit circle, right? And this angle over here is the angle 5 pi over 6. Right? You either know that from, you have the unit circle memorized, so you know that this angle over here is 5 pi over 6, or you know that if this one's a pi over 6, the corresponding one on this side is also going to be a pi over 6, and I just need to know the numerator. And in the second quadrant, the numerator is 1 less than the denominator, so it has to be 5 pi over 6. Or you use the symmetry of the unit circle. This one over here is 0 plus pi over 6, right, to get that angle over in the first quadrant. This one over here is also pi over 6 above the x-axis, but in this case it's pi minus pi over 6. Right? If I do pi minus pi over 6 and I work all that out, I get 5 pi over 6. Right? So my 2 solutions on one period of the graph of the sine function here would be, it would be 3 theta equals pi over 6 plus 2 pi k, and it would be 3 theta equals 5 pi over 6. Plus 2 pi k. Right, so notice it's not just theta equals this time, because it wasn't just sine of theta, it was sine of 3 theta. So I solve it just like I would if it was sine of theta, and I figure out what the angles are, the pi over 6 and the 5 pi over 6. I add that 2 pi k to each one. Remember that 2 pi k represents the period being 2 pi for the sine function. So every time I take another trip around the unit circle, I'm adding 2 pi to my original angle, but I still end up at the same terminal point, so I still have the same sine value, which would be 1/2 in this case. Right, so that's why we put the 2 pi k there. Right, but then, right, to solve for theta, well, I have 3 theta here. Right, so to solve this for theta, and let me actually erase this stuff over here, and let me put the second answer over on the side so that we have, it's a little bit easier to see what's going on, or it'll be easier for me to write it up here. 5 pi over 6 plus 2 pi k over there. Let me get rid of this below here. Right, so I have 3 theta equals all that stuff. To solve for theta, well, just like if I had an equation, 3x equals whatever, to solve for x, I divide both sides by 3. Well, 3 theta equals all this stuff. I need to divide both sides of this equation by 3. Right, that cancels out the 3 and lets me solve for just theta itself, right, just a 1 theta. And then what do I get over here? Well, if I do pi over 6 divided by 3, when you have a fraction and you divide it by a whole number, that whole number multiplies the denominator. Right? That's going to be pi over 18. Right? And if you don't trust me on that, if you do 1/6 divided by 3, think of that as 3 over 1. Remember, when you divide with fractions, you multiply by the reciprocal. It's 1/6 times 1/3. You multiply straight across, you get 1 over 18. Right? So it's pi over 18, and then this is going to be plus 2/3 pi k. Right? Because that 2 over 3 is going to give me 2/3 times pi times k. And then I do the same thing over here for the 5 pi over 6 answer. I divide everything by 3, so that's going to give me theta equals 5 pi over 18. All right, same thing's going to happen there. When I do the 5 pi over 6 divided by 3, I'm going to multiply that 3 times 6 and get 18. And then, again, plus 2/3 pi k. Right, so there are all of my solutions to this particular equation here. Right, pi over 18 plus 2/3 pi k, 5 pi over 18 plus 2/3 pi k. Right, they look different when you have trig equations that just have a theta here. When it's a sine or a cosine function, you have plus 2 pi k at the end. If you have a multiple of an angle, like in this case 3 times theta, you still solve it the same way. It's just at the end, you then have to divide that 3 to the other side, which messes up that 2 pi k. Now it becomes a 2/3 pi k. Right, and then this angle here, instead of pi over 6, it becomes pi over 18. Right, so that describes every possible answer, every possible solution to this trigonometric equation. Now, this problem also asks us to find all the solutions between 0 and 2 pi. So let's take a look at how we would do that. All right, so this is all solutions. All right, all possible solutions to this equation. What I want to find now is all solutions between 0 and 2 pi. Right, so if I just do one lap around the unit circle, I want to find all the solutions to this equation on that one circuit of the unit circle, right, one time around the circle. All right, so the way I'm going to do that is I'm going to start with my first one here, which is pi over 18. All right, well, pi over 18, that's between 0 and 2 pi, right? Right. So it's going to be pi over 18, and then I'm going to do pi over 18 plus 2/3 pi. I'm going to start with whatever my original answer was here, and I'm just going to keep adding 2/3 pi to it until I get past 2 pi, and then that's when I stop. All right, so if I do pi over 18 plus 2/3 pi, well, I need a common denominator here because I'm adding fractions, right? And 3 will go into 18, so if I multiply the 3 times 6, I'll have that common denominator of 18, right? Which is going to be 12. Think about it as 12 pi over 18, or 12/18 pi, right? If I multiply the 2 and the 3 both by 6, I get 12 over 18. And then 1 pi over 18 plus 12 pi over 18 is going to be 13 pi over 18, right? Which is still less than 2 pi, right? Because 13 over 18 is less than 1, right? So I'm still between 0 and 2 pi. And then I'm going to add another 12 pi over 18, right? I'm adding the 2/3 pi, but I'm just doing it in terms of 12 pi over 18 because I'm changing 2/3 to 12 over 18, so it has a common denominator with the numbers I already have. So if I do 13 pi over 18 plus 12 pi over 18, that's going to be 25 pi over 18, right? Which is still less than 2 pi. right? Because 25 over 18, that's less than 2, right? Then let me add another 12 pi over 18 to that. So if I do 25 plus another 12, that's going to be 37 pi over 18. Now, is that less than 2 pi? It's actually not, right? Because if I had 36 over 18, that's equal to 2, right? 36 divided by 18 equals 2. So 36 pi over 18 would be 2 pi. 37 pi over 18 is bigger than 2 pi, so I don't include that one on the list. Right, so from the pi over 18, and then I add this 2/3 pi to it, I get 2 more solutions before I get over 2 pi. Right, then I have to go to my other solution, the 5 pi over 18, and do the same thing. I have to add 2/3 pi or 12 pi over 18 to this one. Right, so if I do 5 pi over 18 plus 12 pi over 18, 5 plus 12 is going to be 17 pi over 18, which 17 over 18 is just a little bit less than 1, so I'm still definitely less than 2 pi. So I take 17 pi over 18, add another 12 pi over 18, so 17 plus 12 is going to be 29 pi over 18. And then if I take 29 and add another 12, that's going to give me 41 pi over 18, but 41 over 18 is more than 2, and so I stop right there. Right, so there's all the solutions I get in between 0 and 2 pi. Right, so solving this equation, there's a couple things here, and that last part might be the most confusing thing about this problem. The first part was, I just go ahead and solve this problem. I add the 1, I divide by 2, I figure out where does sine equal 1/2. That was at pi over 6 and 5 pi over 6. But remember, that wasn't theta, that was for 3 theta. Right, so then I have to take those answers, 5 pi over 6 and 1 pi over 6, divide everything by 3, including that 2 pi k, right? That plus 2 pi k also gets divided by 3 when I do this. So I get these represent every possible solution to this equation, right? This particular problem, though, had a part B where it said, what are all the solutions between 0 and 2 pi? So I start at my first one, pi over 18. I add the 2/3 pi, which, remember, I changed 2/3 pi to 12 pi over 18 just to create a common denominator with these that are over 18. And then I do pi over 18 plus 12 pi over 18 plus another 12 pi over 18. And I keep doing that until I get above 2 pi, and then that's when I erase that last one and I stop there. And then I do 5 pi over 18, and I add the 2/3 pi over and over again as many times as I can before I reach that limit of 2 pi. Right, so depending on how the problems are worded when you're solving this type of equation, you have to read your questions carefully. Right? If it says find all possible solutions, you give this as your answer, and then that's the whole thing. Right? If it says give all the answers between 0 and 2 pi, these are your 6 solutions. Right? If it says give all the answers between 0 and pi, well then it's this one, this one, this one, and this one. These two are bigger than 1 pi. Right? All the 4 on the left are smaller than 1 pi. Right? So you really do have to read the directions carefully and make sure you're giving the answers that you're being asked to give. Right? Most of the time it says find all the solutions to the equation, in which case you do that plus 2k pi, or in this case it's plus 2/3 pi k at the end. But sometimes the questions are worded differently like it was here, and so you have to give your answer slightly differently. You actually have to calculate which ones lie between 0 and 2 pi. Right? So it just adds extra work to do after you actually solve the equation, right? Which is nobody's favorite thing, but sometimes problems ask you to do that. All right, that's the end for this particular example. I'm going to do, I think, one more video where I solve another type of equation that also has not just a theta here. The next one's actually going to have a theta over 2. So it's going to be similar to this, but a little bit different. So make sure you check out that last one where I solve one more trig equation.